All right, this is the last part of section 1.4 that we're going to do. So it's called parallel and perpendicular lines. I don't even know what the section, I don't know what the letter is. We'll just call it 3.4. So if I had two lines like this, we've learned about parallel lines before, but if I have two parallel lines and they're like this, okay, they don't intersect each other.
Are you guys talking? You have an emergency, don't you? I'll probably do it. I ain't gonna hold you yet.
If I have two lines, I got these arrows right here. Okay, they're considered parallel lines. Okay, we've talked about this before. That's nothing new. But we did just talk about slopes.
Parallel lines never touch, right?
So I have two lines right here. They don't intersect each other. I've got the arrows on there. That means they're parallel to each other. So now we've talked about slopes. Okay, we know the slope is the rise over the run. If I did this, if I took 2 points on this line right here, and I figured out the rise, and then I figured out the run, then I did the same thing over here. I did the rise and the run over here. They would be exactly the same thing. So when you have parallel lines, they have the same slope. I'll just write it exactly what I said. They have the same slope. All right? So that's pretty important to understand. We're going to do an example with this in a little bit. Okay? But if I have a line right here and it's parallel to this line right here, both of the slopes are exactly the same. So if I call this line 1 and I call this line 2, and here's how I'm going to show it. I'm going to say the slope of line 1, I'm just making this up. Let's say it's 3 over 2. All right? So let's say the slope of this line is 3 over 2. And if I told you that both lines are parallel to each other, what would the slope of line 2 be equal to? 3 over 2. Because they're exactly the same. Because they have the same slope. So if I told you the slope of this one, and if I told you that the lines are parallel to each other, then they have the exact same slope. They're not always just going to tell you the slope. Okay, they're going to give you some points, and you're going to have to figure out what the slope is. All right, and so what they're going to do in the example, we'll do the example in a minute. I got one more thing to talk about before we get to the example. But what they're going to do is they're going to give you two ordered pairs. Okay, they'll give you two ordered pairs to represent this line, and then they're going to give you two ordered pairs that represent this line. And what you're going to have to do, you're going to have to do some work, find the slope. And then you're going to come over here, you're going to do some work on this and find the slope. All right? I'm not going to even try to make up numbers. I don't think I can make them up in my head. But once you find the slope, you compare the slopes. If the slope of this is exactly the same as the slope of this, then what can you say about the two lines? You could say that they're parallel. Okay? Or if the two lines, if they tell you that they're parallel, and they tell you the slope of one, then you could figure out the slope of the other because they're exactly the same. All right, so that's parallel lines. They have the same slope. Now, we have another set of lines. What are they? We have parallel lines and perpendicular lines. Okay, this is a little bit different. It's a lot of bit different, actually. I'll tell you what, I'll make it like this. And I'm going to try to make it look perpendicular. That looks pretty close. All right. And let's put a little box right there. What does that little box mean? It means they're 90 degrees. That means these two lines are perpendicular. Agreed? So watch this. When you have perpendicular lines, write this down. When you have perpendicular lines, I'm going to write it two different ways, okay? So the first way I'm going to write it the way the book says it the first way. The slope of one line times, that's a 1, okay? That's a slope of line 1. We'll call this line 1. We'll call this line 2. Didn't I ask you not to eat in here? And you're eating in here. And you have a whole desk full of food on your desk. So I will give you a ASD for eating in my room when I told you not to. I just told you. You asked me for what? I just finished telling you. So no, there's no way that you could say anything. So I'm going to just put a little note here to remind myself. ASD for eating lunch or eating in my room. You're still eating. Guys, keep it down. All right, she's not answering. I'll try one more. Hey, Sam, this is Aaron. I'm sending Jaheim down to the office. He was eating in my room after I told him not to eat, and then I warned him again, and he ate again. So anyway, I'm tired of dealing with it, so he can just sit down in the office. Is that okay? Okay. All right. Appreciate it. Thank you. Bye. All right. Mr. Osborne's expecting you. Yep, that's weird. All right. All right. So let's see where we left off. So I'll call this line 1, and I'll call this line 2. These lines are perpendicular to each other. Now watch what happens. Look what happens to the slopes. If I take remember, M stands for slope. That's why I put an M there. Everybody understand that, correct? So M stands for slope. If I multiplied the slope of both of these lines together, if I multiplied the slopes of these two lines together and they're perpendicular, my answer will always come out to be -1. All right? So that's something you may not even considered. Another way to say this, you can say this, that the slopes of perpendicular lines, sometimes I'll use this phrase. I'll probably use this a lot, actually. We call them negative reciprocals. Reciprocal. Did I spell that right? Reciprocals. Of each other. Okay? I have no idea what you're saying. So basically, what's a reciprocal? So if I had 2/3, what is the reciprocal of 2/3? What is it? It's 3/2, okay? Now that's just a reciprocal. But what if I said a negative reciprocal? So if the slope of one line is 2/3, what's the slope of another line going to be? Hold up. Hey, Donna, I was just sending a student down the office. I got Mr. Osborne, though. So Jaheim should be down the office any second. Okay, thank you. Bye. All right, so what it means to be a negative reciprocal is that you take the reciprocal and then you change the sign of whatever the first slope was. So if this was positive, then, I'll tell you what, let's move this over a little bit. Then what do you think this would be? This would be negative, correct. So the slope of line 2 would be negative 3 over 2. So this, if the slope of one line is 2/3 and the slope of another line is negative 3 over 2, they're negative reciprocals of each other. That means that the lines are perpendicular to each other. All right, so I can tell if they're perpendicular just by looking at the slopes. You're going to have a question on a quiz and a test. It's going to ask you, it's going to give you some points to find the line. It's going to say, are these lines parallel to each other or are they perpendicular to each other? And show me why. All right, so what you're going to do is you're going to find the slope of one line, you're going to find the slope of another line, then you're going to compare them. If the slopes are equal to each other, then what kind of lines are they? Parallel. If the slopes of the lines are negative reciprocals of each other, then what kind of lines are they? They are perpendicular. Anybody hear what I just said? Okay, if you find the slope of these two lines and they're negative reciprocals of each other, if one is 2/3, the other is negative 3/2, it doesn't always have to be 2/3. You understand that, right? But if the slope of one line happens to be 2/3 and the other one is negative 3 over 2, it's the negative reciprocal, then what do you know about these two lines right here? They are what? They are perpendicular. I'll just put the little symbol for perpendicular, okay? What if the slope of line 1 was negative 5 over 3? What would the slope of line 2 be if they were perpendicular to each other? Wouldn't be the same, not perpendicular. It'd be positive 3/5. You said negative 3/5. That's what I heard. Well, I heard negative, sorry. Okay, so look, these are negative reciprocals. What do I mean by negative? Does it mean that the second line is always negative? The slope is negative? No, it just means opposite, right? So when I say negative reciprocals, if you wanted to use the word opposite, okay, you could do that as well. Yes. Well, kind of, because I could give you, it's a good question. So what if I gave you the slope of one line is 4? Then what is the slope of a line that's perpendicular? I'll put a little perpendicular symbol right there. So what would this perpendicular slope be? Or what would the slope of the line that's perpendicular to this line be? So what's the negative reciprocal of this? It is, very good. So it's negative 1/4. So even though technically it's not a fraction, it kind of is a fraction, isn't it? Can't we write every single number as a fraction? Yeah, we could always put it over 1 if we needed to, right? Okay, everybody see that? All right, so if I take the reciprocal of 4 over 1, it's 1 over 4, but then I got to take the opposite sign. It'd be negative 1 over 4. Okay, so the perpendicular one's a little bit more confusing, but it's not really that bad. What about this thing? I really didn't talk about this too much. Let's take a look at these slopes that I did over here just as examples. That negative 5/3 and the positive 3/5. If I multiplied those two slopes together and got an answer of negative 1, then they're perpendicular. So you could always do that as well. All right, I just want to show you that, because this is what they say in the book right here. Okay, the slope of one line times the slope of the other line. If you multiply them together and your answer is negative 1, then those two lines are perpendicular to each other. All right, so let's just try it. What's negative 5/3 times 3/5? Well, you could go negative 15 over 15, but what's an easier way to multiply those together? That 5 does what to this 5? Cancels out. What does that 3 do to this 3? Cancels out. Now, when I say, a lot of teachers say cancel out, that's perfectly fine. I got no problem with teachers saying cancel out. I say it a lot too, but really they're dividing each other. What's 5 over 5? It's 1. What's 3 over 3? It's 1. So they cancel out, that's true, but they really become a 1, don't they? So it's not like it just goes away. So I still got a negative, and what do those fractions come out to be? A 1, so it's a negative 1. So that works. Anytime the slopes of two lines are multiplied together, your answer should be, did I say the slopes of two perpendicular lines, I should say, then the answer is negative 1. All right? What do we think? I am recording it. I got the whole thing. I even got the phone call and everything. All right, let's do the example. We are ready now to do the example. I hope you're writing all this down. They're going to give you 5 different points. So write this down. And they label them with capital letters. All right, so the first point is negative 3, 4. The second point, we'll call point B, is 3, 2. Point C is 1, negative 4. Point D is negative 2, negative 3. And then point E is 0, 3. All right, here's what they're going to ask you. They're going to say, tell whether they, or the lines, I should say, instead of they, but I'll just put they are what? Parallel, right? That's a symbol for parallel, just 2 up and down lines like that, or perpendicular, or neither. Okay? So if like you have a slope that's 5/7 and another one that is 2/3, is there any relationship between those at all? Are they parallel? No, they're not the same. Are they perpendicular? No, they're not negative reciprocals, so they would be neither. Okay? So what we're going to do is they're going to give you, so this is part A and part B. They're going to give you 2 lines. Now, how many points does it take? What's the least number of points does it take to make up a line? 2 points. So they are saying, okay, let's take a look at line AB and line CD. Okay? So what I want to do, so line AB, it's these 2 points right here. All right? You don't have to do this, and I really don't want you to do it, but you could, if you wanted to, plot both of the points and see a line that goes through those points. Okay? I'm not going to do that right now. All right? But what I want to do is I want to see if this line is parallel to this line, is it perpendicular to it, or is neither one of those things true? Like, how in the world can I just look at these numbers and figure that out? Well, I can find the what of those numbers. Of these, I'm sorry, not of those numbers, but of those lines. I can find the slope of the lines, right? That's what we're trying to do. We're trying to find the slopes. So line AB. Well, let's figure out, let's put, that's A, correct? And this is B. And on the homework that you were supposed to do this weekend, what did you have to do with those 2 points? You had to find the what? Find the slope. So let's do that. Let's find the slope of this line. And then after we do that, then we're going to find the slope of this line. Then we're going to compare them. We're going to look at them. If they're both exactly the same, then those 2 lines are parallel. If they're negative reciprocals of each other, then they're perpendicular. If neither one of those things are true, then you just say they're neither. All right, so let's find the slope. The slope is it's the rise over the run. Do you remember that? But what is the rise? How do we do the rise? It's y1 minus y2 over x1 minus x2. It doesn't matter. Okay, remember, listen, this is very important. She brought up a good point. She said, I thought it was y2 minus y1. Well, actually, I think the book actually writes y2 minus y1. But it does not matter. As long as, listen to me, it doesn't matter what order you subtract them in, as long as you subtract the y's in the same order as you subtract the x's. You serious? You dead serious. Stay after class, you're going to pick up the whole room, okay? So here we go. So we subtract the y's from each other. And again, it doesn't matter what order you subtract them, as long as you subtract the x's in the same order. I hope you're listening, because this happens a lot. And I can see people are laughing, you're trying to make jokes, your heads are down. Not everybody, obviously, but too many of you. So let's subtract the y's. 4 minus 2. Now, if I go the first one minus the second one, I have to go the first x minus the second x. I have to, or it's not going to work out. All right, let's see what that is. Oh, let's just write it down here. 4 minus 2 is 2 over negative 6, and you reduce it. Always reduce it. So what's the slope of line AB? It's negative 1/3. Now, what we're going to do is we're going to do the same exact thing, but we're going to find the slope of CD. All right? I have to push this. There's the C and the D. So I just found the slope of AB. All right? There's a line, right, that connects A and B. All right? I just found the slope of that line, and it's negative 1/3. So now what I have to do is do the same thing with C and D, because they say, is this line parallel to this one? Is it perpendicular, or is it neither? So now I got to do the same exact thing, but I have to do it for CD. So now we're taking these 2 points right here, and I'm finding the slope of those 2 points. Now let's just do it right here. So the slope of these 2 points, I'm not going to write that y1 minus y2 again. I already wrote it once, okay? But how do you do it? You just subtract the y's. Again, it's CD. It's these 2 points right here. So let's go the first minus the second. So it's negative 4 minus negative 3. It's important that you put minus negative 3. Now we do the x's. Okay, always do the y's, put it on top. Because remember, it's rise over run. Rise is going the y direction, isn't it? Okay, so it's rise over run. Now let's do the x's in the same order. If I go the first y minus the second y, I have to go the first x minus the second x. So let's do that. That's 1 minus negative 2. All right, and then we just work this thing out. Minus a negative is plus. We got a minus negative down here. That's plus. Negative 4 plus 3 is negative 1. 1 plus 2 is 3. Now what we're going to do is we are going to compare the slopes. Compare this slope to this slope. Obviously, they're the what? They're the same, right? So if they are the same, then what kind of lines are these two lines? They are parallel. Okay? And that's the answer right there. But you need to show why they're parallel. You have to show me that they're both exactly the same slope. If they're both exactly the same slope, then they're parallel. On a quiz or a test, is if I give you this question and the only thing you write down as an answer is this, I'm marking it wrong. You hear what I just said? If I give you this question on a test and all you do is just say, oh yeah, I remember that one from when we went over it in class. Or you might say, I have no idea, but I got a 1/3 chance of getting it right, so I'm just going to pick one of those, and I'm going to pick parallel and put it down. Okay, even though parallel is correct, I need to see why it's parallel. This is part of your answer. All this stuff, and all this stuff is part of your answer. Okay, and then this is your final answer. It's parallel. All right, let's do another. Tell you what, you wrote all this down, but I'm just gonna erase this part just to give me some room so we can see those points right there. All right, let's do another one. Change colors here. This time we're gonna look at line AE, and we're gonna look at line BC. Okay. So line AE. Go ahead.
Are they going to give it, like, we have to do each a different combination of them?
They're just going to give you the combinations that they want you to know. Okay, you're not to do every one. They just told you, I want AE and BC. Because this is a line, this is another line. Tell me, are they parallel, are they perpendicular, or are they neither? Okay, so they'll tell you out of all these. In fact, they gave you 5 of them, but I don't think we used D at all, did we? Or did we? Did we use D on that last one? Yeah, did we use them all? Yeah, it doesn't matter. But let's just do AE. So what I would do is this. I would just write down the point for A and write down the point for E, 0, 3. And let's just do the slope, okay? All right, so let's find the slope of this right here. So we should be able to do this pretty easy now. So it's the rise over the run, right? It's the y's over the x's. So I'm going to go 4 minus 3, because those are my y's, right? The 4 is the second one, the 3 is the second one. So I go 4 minus 3, and then I go the x's, negative 3, what? Minus 0. And then we just work this thing out. 4 minus 3 is 1. Comes out to the same thing, doesn't it? Negative 1/3. Does that mean these two lines are parallel? No, because we don't know what the slope of BC is, right? AE, we know it, but we don't know BC. So let's find BC. Well, there's B, there's C. So let's write those points down. 3, 2 is B, and C is 1, negative 4. And let's do the slope. Slope is rise over run, so we subtract the y's, so it's 2 minus, what is this? This is not just a 4, it's what? It's a negative 4. So it's 2 minus negative 4. That's where a lot of people go wrong. Okay, they just see the minus and they go, oh, it's 2 minus 4. Well, it's 2 minus negative 4. Now subtract the x's. It's positive 3 minus 1, so 3 minus 1. Let's see what we get here. Add the opposite, right? 2 plus 4 is 6 over 2 is what? 3. So look at our slopes. I got one slope that's negative 1/3. I got another slope that's positive 3. So what are these two lines to each other? They're perpendicular. Okay, how do I know they're perpendicular? Because look at the slopes. They're negative reciprocals of each other, right? That's a negative 1/3. If I flip it, that's a 3. If I change the sign, it's positive. Yep. So perpendicular. All right, so these two lines are perpendicular. That technically is your answer, but again, I need to see all of this, okay, for your answer. I got to see that you know why it's perpendicular. What do you think? It's not too hard, is it? Okay. So, let's see. What did I give you? 23 to 36. You got a pen? So here's your homework.
Thank you very much.
It's 3-4. We're going to call it section D. Oops, there goes my marker again. Okay, we're going to call it D. This is our fourth lesson from section 3-4. And it's pages 133, 134. I mean, it's on that thing I gave you today, but this is for anybody watching on YouTube. There it is. That's your homework.